Hey, if you're watching this video, I'm going to assume that you already know that the corresponding sides of similar triangles are proportional to each other. But what you might not know is the fact that this is also true for different parts of our similar triangles as well. For example, if we have two similar triangles, let's say we have one triangle here and one triangle here, and we have a height or altitude actually here and here, and let's label our triangle so we can talk about the different segments as we need to. So A, B, C, D, and we have here F, G, H, J. All right, so in these triangles, both these triangles, we can see altitudes. If you don't remember what an altitude is, I'll remind you briefly. It's a line going from one vertex of our triangle to the opposite side, and it meets that opposite side at a right angle. Sorry. Okay, so our altitudes are also proportional to the corresponding sides. So I'll show you what I mean right now. All right, so you already know this, and I'll show it to you anyway. If triangle ABC is similar to triangle FGH, we already know that AB over FG is equal to BC over GH, which is equal to CA over HF. But what we might not know is this is also equal to AD, which is our altitude of the first triangle, over FJ. So that scale factor remains the same throughout, even if we're talking about the altitude. Okay, so now we know that not only are the corresponding sides of our similar triangle proportional, we also know that the altitudes will be proportional as well. And now we're about to see that so are the angle bisectors. So alright, so really quickly, let's just look back at this. We remember these are the sides. AB over its corresponding side FG will give you BC over GH, which will give you CA over HF. Alright, so that's stuff we already know. So let's throw the angle bisector in. So we bisect angle C and bisect the corresponding angle, angle H. And let's say this is point E, and let's say this is point J. Alright, so now we can throw this into the mix. All these three things, these three corresponding pairs of sides will be equal to CE over HJ. So where did I get CE from? Angle bisector of the bigger triangle on the left over HJ, which is the angle bisector here. So all I'm trying to say basically is that the angle bisector can join in this proportion just like the altitude could. Okay, so we're steadily building on our knowledge here. We already know about the proportionality with the pairs of corresponding sides, and we now know also that the altitudes behave in the same way as these corresponding sides, as well as the angle bisectors. So now the last thing that we're going to add to that list of things that behave in the exact same way is the median of our triangle. And so let's just make sure you remember what the median of a triangle is. So I can pick a side, so I pick side AC, just out of random. So the side AC has a midpoint, so let's call that midpoint, let's say X. Alright, so if I take the vertex opposite that segment and I join it to the midpoint, that is a median. It just so happens that in this case it looks a little bit like an altitude, and it also looks a little bit like an angle bisector. But what differentiates the median is the fact that this and this are congruent. These two things are congruent to each other. Alright, so let's say we do a median for this second triangle. So let's say right here is the middle of FH, which would mean that that's equal to that. That's our median here. And let's call this point y. All right. So now we can add this to our proportion, and we see that bx, which is the median of the first triangle, over gy, which is the median of the second triangle, is equivalent to all of the proportions that we came up with before for the corresponding sides. All right, so overall, what I want you to get from what we just did is the fact that corresponding sides behave just like corresponding altitudes, which behave just like corresponding angle bisectors, which behave, you got it, just like medians, corresponding medians. Okay, so let's take a quick look at an example. Okay, so in this example, we're being asked to find the value of x. But before we do, I do want to caution you to pay attention to the similarity statement, because that's what's going to tell you which angles and which sides are corresponding to each other. So in this example, A corresponds with F. Those are the first letter of each of these triangles. B corresponds with D, and C corresponds with G. All right, so as long as you know that, then we are good to go and we can start this question. All right, so as you can see here, there is a line going from A down to P. What is that line called? I know that we said that our altitude or median and our angle bisectors all look a little bit alike sometimes, but there is a clear indication that this is cutting this angle in half, which means that this is an angle bisector and so is this. So we're dealing with angle bisectors in this question. Okay, cool. And angle A is being bisected and angle F is being bisected. And fortunately, those are in fact corresponding angles, so we are good there, which means that our corresponding angle bisectors, cor for short, are AP and FQ. Okay, so we also need at least one pair of corresponding sides in order to set up a proportion. So we do have sides going on here. We have this side AB, which is 15, and we have FD, which is 12, and fortunately for us, those are actually corresponding sides. AB and FD are corresponding sides, so that is awesome. All right, so let's set up our proportion. AB over FD will be equal to AP, or bisector, over FQ, or bisector in the second triangle. So we can go ahead and fill in our values. So AB is 15 over FD, which is 12, is equal to AP, which is X, what we're trying to find, over FQ, which is 8. Now we can go ahead, cross multiply, and we get on the left side that 8 times 15 is equal to 12 times X. Well, 8 times 15 is 120, is equal to 12x. Now, our final step, we want to isolate that x, so we can divide both sides by 12, and we get that x is equal to 10. All right.